In my specific instance, it's going to do with one hand. It's going on the side of the machine here, or on the wall. I don't know yet. But that's more or less the plan. So we bent it on this hydraulic press, which was broken for 1.5 years, and I finally fixed it. This is the pressure manifold. I think that this is pressure manifold, and this high pressure fitting was 250 bar. It basically blew out. Now it's still leaking a little bit, so I repaired it, but this goes back into the tank. So just like the tiniest little drop that comes out of here. But considering like there's enough oil in this, I don't really worry about it. So I first need to clean up all the metal. Bending it is very easy now. I made a custom program using Claude code to basically decode the settings on the press brake into something I can actually understand, because it just gives you some random Y value. So it says, let's say Y 5 millimeters. But if you need a bend which is 90 degrees, that doesn't tell you anything. So I made a program with Claude code to basically do 2 or 3 bends with first initial gas values. Then I basically some mod makes a plot based on physics, and within like 2 or 3 bends, so let's say you do 90, you do let's say 135 and 110 degrees, something like that, then it's basically spot on. So I'm very happy that I made this. Only took a few hours. So let's continue with this. Only one more left, right? Yeah, the downside of aluminum is super soft. So, well, as I said, this has been standing outside for 2 or 3 years. You get these kind of blemishes on there. It's kind of deep, so you can't really take that out. But it doesn't really matter. So, it's a compressor letting some air out. Yes. So it doesn't really matter. Just pick the nice side and you just bend it that way. Let's do the last one. Let's take the Burrs off first. So I was actually just filming a time lapse for my video because I'm making a YouTube video about fixing my hydraulic press. I made the first part, but then it's always nice to add like a time lapse that you make a few more of them. And I thought instead of just making a time lapse and just putting it at the back of the video, I thought let's try to go live. Should really make a jig for this, where this machine is just mounted, where this thing is just mounted on the linear rail, so you always make perfect straight lines. Like, it's not too bad. If you look really closely, then it's not perfectly straight. Yeah, I have loads of linear rails. I still have some on my... I recently built this rack because my workshop is kind of small. Where do I have? I have rails somewhere. There, you see some bunch in the back. Some geared racks, I have all kind of stuff. So it should be... Oh wait, I'm blocking my camera. So it should be pretty easy to make that, yeah. Yeah, I have loads of them. I have another section of like 2 meters somewhere. This is just my pile of like random crap. Here's more random crap. And there's more random crap. And more broken machines. So there's enough work to be done. All this needs to go into the trash. Then I need to finish my retrofit of my machine. But now I have all the correct tools. It should be pretty easy. And all of these need to go away because these things, I don't know if you ever use them. These things are a pain in the ass. Yeah, my shop is kind of small. So this is probably like 40 square meters. Like this compressor needs to go outside. And this machine is obviously very, very big. I don't know if you can see it, but it's very, very big. But I have another section of, well, it's currently as a carport, which is outside of this. I think it's another like 4 or 5 meters. I will attach that to this garage somewhere next year. So that should add another like 30-40%. But yeah, I have, well, as many people have, my dream of course is like a giant workshop. I don't know where you live, what the prices are, but my house was already like 400 grand and it's not that big. So anything which has like the space for a workshop or something like that is easy, like 600 to €1,000,000 here, which is a lot of money. I already find my mortgage, which is like 2 grand expensive, so I can't imagine spending 4 grand or 6 grand. But yeah, what I should really do, because well, I just recently got this Gweike fiber laser thingamabobby, like I think like a few weeks ago. As you can see, this machine is giant. What I should really make is, you have these conveyor things which have like a belt sander, and then they have like usually these wheels, a few of them like rotating. I should make something like that because that whole backspace, well, this whole piece in terms of height is empty. So it should be pretty easy to make something small. Or just make something with a linear rail. I'll have to see on how many jobs I do. Or I could even see if I could modify this machine so I just attach a small one of this to the machine and just get it to move up and down. That would also be a solution. Did I do this? Yeah. Looks good enough for me. So now it's off to the press, and then I need to figure out how to hang up my phone. Oh, wait, I have something for that. Let me get some of my things. Let me see what size it is. I have, is it a small one or big one? Let me see. Give me a second. Let me see if this one fits. Otherwise, doesn't it? There's 2 different sizes for these holes. I can't figure out if I have the correct one. Then I need to get it from my other camera. Here. No, it's the same one. Here it is. No, also the same one. I am confused. I have too many. Oh, this one works differently. Interesting. It should fit. It's like spring loaded, and then the smaller size starts appearing. That's difficult to do with one hand. There we are. Okay. So quickly. This is the controller press brake. And this is like, let me see. Can you see it? This one is quite basic, which has its pros, but also its cons, of course. Hey, I'm doing pretty good. It's the first time I really do a live stream, so I'm just hanging out. How about you? So in a hydraulic press, this type is a torsion bar. Maybe I have to remove it anyway to show you. So this is a torsion bar machine. Do I have a step somewhere? No. Then I just go into the back. Let me quickly show you. This is a torsion bar machine. So you can see here a big, well, bar in essence, and two connecting things to the ram. So this basically works the way same as a, like many cars have a torsion bar from the left to the right side. And the whole reason why you use that is because it's a cheap machine. So with better quality machines, you just control these things perfectly. You have encoders on both sides, and you just keep it perfectly level during the bend. But that costs money. So what these cheaper machines do, they have this torsion bar to compensate for the small little changes, because if one side is lower than the other one, you basically have to bend this giant piece of bar. So of course it tries to fight that. And this is not the greatest, but this machine cost me $4,000 for about a 30-ton machine, which is extremely cheap. I got this from China directly, and that was quite a bit of an adventure. And this controller is a controller you see action on many machines, even on machines which are like 30 grand, 50 grand. But I find it kind of limiting, but yeah, it works. Let me think. So what you see here, this YP, this is an offset in millimeters versus a reference. So my current reference, show you my current reference is basically when this tool touches this point, or touches the bar. It's not perfectly accurate, but it's good enough. So this number basically means that this point is about 2.58 or whatever, 2.59 millimeters above this. And how I figured that out, let me quickly show you my custom program, which I made with Claude code, because I was trying to figure out, well, how do you figure out how many millimeter means what? So let me quickly show you. This is a program I made with Claude code. I call it brake calibration. So in here, you have a library, you have your punches. Well, this graphic is not really good, but in essence, it goes about the data. It's just some random graphic I took from the internet. So here you have your tip angle, which is basically this angle here. So this is 84.5 degrees. The radius, I truly have no idea. So, and then you also have your dies, which is basically the bottom piece. So today we're working with the 10 millimeter opening, 88 degrees. And then you have a setup. So you select a material. In this situation, This is one which was already saved, so aluminum. I don't know for sure if it's this type, but yeah, it's good enough. And here are old bands which were made basically. So here you see that Y value again. So if you want 135 degrees for this material in this setup, you need to have your Y value on about 4.66. And let me see, here you can see 90 degrees, and we need to put on 2590. So this is based on calibrations we did before. But if you do a new calculation, it basically tells you the same. So it tells you 2.59. It says the confidence is high. Why? Because it's based on old measurements. Here is a source exact match. But if you want something slightly different, it also works. So if you have a 1 meter wide band, you need 136 kilonewtons, which would mean 13.6 tons. This RI, I have no idea what this means again. Natural inside radius, blah, blah, blah. So I basically got Claude Code to do a bunch of research and all this physics and all of these kind of things. So this thing is kind of, here it gives you some warnings because 90 degrees close to the die angle. So you get some different kind of physics, blah, 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 blah. So I need to quickly check in Fusion what my measurement was. So here you have the part. And we need to know this distance. I can't remember, it's 16 millimeters. So now I need to go back to the machine and set the X value, because the X value is like the thing that goes forward and backwards. Let me quickly show you. So the X value controls these fingers, so they go forward and backwards. So we want a band at 16 millimeters. So if I set this manually at 0 when it is at this point, so it's close enough. So if I fill in 16 millimeters, this machine gets, well, to here somewhere. So when we hold our metal against it, it's exactly in the correct position. Yeah, bending is something I'm very new to. As I said earlier in this chat, I bought this machine 1.5 years ago, something like that, from China directly. So it was quite a interesting haul. So it went on a container, came here. Obviously it didn't work, or not as expected. So I had to do some fine tuning. Then the hydraulic hose blew out, started a whole leak on the machine. And after that, I didn't really touch it. But at that time, I also didn't have a fiber laser. So I wasn't really in a situation where I really needed it. In the meantime, I focus on all this kind of other projects that are going on here. Okay, so let's. Oh, no idea what happened. I pressed the button and then closed. So let's turn the machine on. So this YP value is correct, as we saw earlier. Now we just need to change this XP value. You can actually put in programs in here. I haven't really figured that out. So the second band needs to be at this value. So we need to remember it for later. But let's set it to 16. Enter. So now you see 16 millimeters here. And let me quickly press the button. Go here to start moving it. And here you can see. You might be wondering, why does it go backwards and forwards? That's very simple, because it uses some geared motor. So in order for it to get into the correct position, it needs to go up and down like 3 or 4 times until it magically ends up at the correct position based on my encoder. Of course, this is rounded a little bit, but it's quite accurate. Let me get my part. So quickly get the metal parts, and I put them somewhere. So here are our parts. So the first flange is basically here, which is at a 16mm point. You need to figure out which is the nice side and which is the less nice side. So I think this is the nicest side. It will bend it up, so we should go to this side. Something I want to try and I've never done before is put some tape in here, because you get these bending marks. And I saw some videos online that people use all kind of Teflon blankets and all this kind of stuff, which I obviously don't have. So I'm just going to put a small piece of tape here and let's see if it works. So let me park this here quickly. Let me go get some tape. And let's see if that makes any difference. So that's the first. Let's give it a try. What was the nice side again? This has a big blemish, like a scratch. So let's put this on the bottom side, which means this needs to go like this because it bends up, I think. So let me put it on this button, press the pedal in the bottom, and then tape correct. Let's see if it works. Yeah, you still see like a slide bend line. This might be mostly residue. I think actually, let me see. Yeah, it seems to clean up perfectly. Okay. Something new I learned. So I think I need to buy these Teflon sheets or something like that, so I don't have to replace this tape all the time. So I'll quickly bend all of these. This goes kind of quickly. And the most work is of course taking the tape off. Pretty happy with it. So quickly take the others up. Of course creates a bunch of mess. See which is the nice side. I think this is the nice side. Ugly sides. Okay. This is dirtier, it bends up, so let's pick this one. I guess this is kinda why these, when you buy these big sheets normally for laser cutting, they come with foil. And my guess is with bending, they just leave this foil on for this exact reason. So I need to figure out the source for that at some point. Another one. All kind of stuff falling. Yeah. So this ugly side bends up, so okay. last one we have just has more scratches. Yes, so let's make this the bottom side. Now we need to set it to the next size, because we need to put it in like this and then bend this part. It was 75, 6 point something. I forget it again, so let's have a quick look at the computer. In the like nicer machines, you can just upload even the 3D file, and it will just do everything for yourself. You can see 75.658. 75.658. So now I need to remember that. 75.658. Holder again. So 75.658. This machine only goes to 2 digits, so quickly check. 658. Yes, the measurement is correct. So we press enter. 75.658, yeah, runs to 66. When we press the button, the bag gauge will automatically position itself. And apparently got it in one time. So remember, it goes like this. Is this a correct one? Let me get my sample part. Normally you just make a drawing, but I don't know. Where did I put my sample part? It was here. No, it's not here anymore. So here's our sample part. So we have a position like this, and then it will bend this angle. I actually wanted this to be more sharp, but this die, because of the angles, just can't do this. So I need to buy some different sizes. I kind of wanted to have like this, so when it's against the wall, it's kind of like hanging a bit towards you. Now it's just kind of like straight. I wanted it to be a little bit like this. And here you can see the marks, which I was talking about. So without the tape, you get this kind of mark. Yeah, can't really wipe it off. It's a little bit difficult to see, but you see it here. And by using the tape, it doesn't do that anymore. After this, I need to stop because it's a little bit late already. So let's quickly finish these up. Otherwise my wife gets angry that I spend all my time at my machines. So you put it in like this, change the button, press the button. There you have a part. I put here so you can put some, like 3D print some labels if you ever want to do it. And here I put holes. If these tools are too heavy, I can always put like a sheet metal gusset, like a triangle in between this. I'll just pop rivets into these holes. At least that's the idea. But I need to find a better solution for this tape. Either a thin sheet of some plastic or whatever. Because putting the tape on and taking it off takes kind of a lot of time. Or just buy the correct materials, but I'm doing this on like a hobby scale, so it's not really interesting to buy big volumes. But I would imagine like a thin piece of basically some plastic foil should already be enough. Like the stuff that normally comes on this. I think you can probably buy it somewhere. Because in terms of bending, this is now like the most work, is putting the tape on and taking the tape off. As you can see, if you have this prepared, you can bend 1,000 parts by hand in a day if you wanted to. Two more to go. I'm kind of thinking, you have this like baking paper, like you put on the trays to ensure stuff doesn't like stick to your tray. I'm wondering if that works, or even like a really thin piece of fabric, like a really thin microfiber towel. I guess it kind of gets damaged. Like you need something disposable and cheap and easy to take off. Yeah. Okay, if stainless steel wasn't that expensive, and if I had it, I would make it out of stainless steel. Like it cuts a little bit cleaner, it doesn't rust, it's stronger, so you don't get these like scratches that quickly. Like aluminum, you really need to you really need to anodize it. Otherwise, you get scratches on there so easily. The last one. So now I have to take all of this tape off. Let me quickly check the time. Oh, I have quite a bit of time. I thought it was already nearing 12. I need to take all of this tape off. Turn the press off so we don't have this whining noise anymore. Like I know Meta has these Ray bands. Is it Meta? Yes, Meta. There's these Ray bands, like these glasses. We then have a camera in there. I'm kind of wondering if like the battery lasts long enough and if it's good enough for like streaming on things like YouTube. Because even for a YouTube video, moving the cameras around is like the vast majority of the work. And if you could just have cameras, well, this Meta glasses, because I wear glasses anyway, which has the camera and then I can wirelessly stream. You can see the bends. Like you can see the tiniest little mark in the metal, but yeah, it's obviously you're bending it. But here, yeah, this is just the material. Yeah, it's difficult to see. See here like a little bit of roughness in the material. There are different grades of aluminum. Some do it a little bit better than the other ones. I have no clue what this is. I just bought this a long time ago. As I said earlier, this has been sitting outside in the mud for like 1 or even 2 years. So in some way it's kind of impressive. It still looks this good. I think I need to do like a slight bit of acetone to get this residue off. Because you can kind of see, ideally you don't want anything with glue, because when all this pressure comes on there, the glue kind of hardens. Yeah, that would be an interesting idea if you put some. I think people kind of do that, putting some oil on there to make it slide a bit better. Kind of want to try. Let me quickly see if I have some. I have grease and oil. Let me have a quick look to find some random piece of aluminum. Bend this back. Mostly flat again. Let me think. You can either use some oil. You could even use hydraulic oil. You know what? I'm just going to dip this in the hydraulic tank. So this is a press brake, and if you do it like this, then it's indeed a guillotine. Do not put hand into, as you know, very interesting language. And it tells you some more things. If this breaks, it not flies into your head. Oh, here it only breaks your hand. That's not too bad. This crushes your hand. And this hits your head. Okay. Caution, piece injury. So you know all this language, that it really means this machine is very safe. No, obviously it's not. Silicone grease. I have all kind of greases here. Let me see, what is this? Mobile grease. I think I kind of want to try some oil. Let me think. Oil or grease? Let's try some grease. I have the grease gun somewhere here. I saw it. Yeah, I recently reorganized my things, which means obviously you can't find anything. This place has been a mess for quite a while. I've been doing so many renovations and all this kind of stuff. Grease gun. Where are you? Is there any grease gun here? Nope. I'm pretty sure it's on this rack. This rack isn't that big. I'm pretty sure I saw it before. Yeah. I thought it was hanging somewhere. No. Also miracle glass. No, let's just use that. Wait. I find it. As you can see here in this well-organized pile, there is a grease gun. me see if I can do some one-handed greasing. Yeah, that must be good enough. I need to get my finger dirty. Put them on a knife. If this solves it, it would make my life easier. And here's my random part. What do you say? It's also a little bit of grease in here. Let's turn the machine on again. Pump on. Automatic. Green light. So we're going to do a 90-degree bend, or at least something which is close to it. Something like this. Let's press the button. Did they solve it? Now you can still kind of see this bend line here, but it's definitely better. Yeah, I really need to try that Meta camera thing. I have no idea what it cost, but I was literally talking about that not very long ago. And here, this is what happens if you put some wrong parameters. This metal is bent. But I think this is not a bad idea. Like, this gets pretty close. Like, you only have this faintest line here. But definitely something I'm going to do going forward. Let's turn this machine off. Switch off so it doesn't light on fire. Let me think. Yeah, I need to get this tape off. But next time I will definitely. Ooh, let me see. Ooh, cancel. How do I go back? I go one back. Nah, well, of course this is metal and there's like 30,000 kilos going on there. There's not as much metal here, so you can see here. This is all hardened, but you can see here it's like bent out like slightly. But this came with a machine, so I had literally no idea what I was doing. This tin of band is only meant for like really thin material. So it's not really the metal, which is, my hands are dirty. Hey pair. I'm just quickly cleaning my hands because it's dirty from the sanding. Let me quickly check the time again. I definitely need to. Oh yeah, some time. Now back to our exercise of removing tape. There's some translate sign next to your message. What does it mean? I never live stream, so I literally have no idea. So this ended up pretty good. I think there's a thin sheet of plastic and the grease trick probably makes this like quite a bit better. But like, this machine is really new to me. I just literally fixed it yesterday. So it has been broken for 1.5 years. I fixed it literally yesterday, and this is probably, in terms of a real part, probably the first one I made. Yes, these are very simple. These are just 90 degrees. this specific die can't make angles smaller than 90 degrees. So I need to get some different ones of these so I can make different angles. I actually wanted this to be slightly different so that this was like a little bit slanted like this. Ah, okay. So I wanted this to be, now it was 90, I wanted this to be actually bent inside. So like 110 or whatever. So it was, like now it was, let me show you, now it will stand like this, I want it to be like this. Yeah, the camera lens deforms a bit, it's actually 90 degrees. I know, I checked a few times. There. Just park it here. But this is, as I was saying, basically the first like real part, which I've made on this machine, and I'm quite happy that it now actually just works. Because my workshop is not very big, and having a machine which doesn't work is kind of an issue. And at this moment, almost everything works. It's a new record. Except the mill. The mill is broken. So I bought a mill for quite a bit of money, with the idea of it being like good quality. I did all the measurements of the machine because it's from like... these, let me quickly show you, because of course there's new chatters coming in. This is my fiber laser. So I have this for a few weeks now. I did all the sanding here, so quickly take all of that stuff off. The fiber laser basically uses high power laser. This one is up to 1.2 kilowatts, which is good enough for like probably 8 millimeters, 6 or 8 millimeters of aluminum, and if you use oxygen you can probably do like 10 to 12 millimeters in steel. So this is a fiber laser, and in the bottom you see all the circles that fell out, and I nested them so closely, as you can see. I put them like 0.15 millimeters apart, and as you can see, it can actually cut that kind of, like, for all of these parts this thing exists. It means you can kind of get crazy resolution with this. And in the bottom there's sand, because of course lasers just go through things, so the sand is kind of wet. Well, now it's actually very dry. But if you didn't put air, it would just cut holes in this bottom metal tray. So lasers is kind of dangerous. So this is a dual machine. So it has fiber laser here. There's also a welder, like one of these 6-in-1 things, but also has a CO2 laser. So here you have a CO2 laser, which is like goes there. I need to realign the lens, so I actually didn't use it yet. It's 130 watts, so that's pretty good. I made some Gridfinity things before, which I CO2 laser cut. Let me quickly show you. Yes, CO2 lasers go through plywood, but fiber laser, which is a different kind of laser and different wavelength, etc., they can go through metal. So this machine has both. So it's the Gweike M3 Ultra. So it has 130 watts CO2 and 1.2 kilowatts of fiber laser. So with the fiber laser you can do metals, with the CO2 laser you can do like most plastics, woods, etc. So this is something I made before, because I always had to little screws, and locally I spent way too many money on screws. So whenever I bought this machine, no, not this machine, this machine, I ordered a whole bunch of screws, like good quality ones, because from China you can actually get good quality. So most of these, let me think, these are 10.9s. Very difficult to get 10.9s here. In China, pretty easy. So I basically bought all the screws, because buying it locally in like really ends up being very expensive, and you always need a lot of screws. So I still need to put labels on here. So this is Gridfinity. Normally you 3D print these things. So I made this grid out of wood with my old CO2 laser, who now went to my friend in the UK. And there's like a lot of screws because you need a lot of. So here you have countersunk. Here you have normal cap screw. Yeah, all kind of sizes. Cap screws I have the most sizes of because you use that the most often. Here's a bunch of rings, spring ring or whatever it's called, spring washer, normal, some button heads. I don't really use these often. Some washers, and I have a bunch of screws here, and there's more screws here. So I actually have enough bins, and there's even more screws here. And there's some random crap. There are some more screws here, and here you see all these Gridfinity bins, which I basically printed. Let me guess. Probably printed these 6 months ago or so on my bamboo printer. So I need to. Yes, these are all Gridfinity. So there's a guy on printables. He has a. Let me think how it's called. He has a FreeCAD. I don't like FreeCAD, but he has a FreeCAD script, which basically allows you to generate these things. Yes, screws. You always need screws, and buying them locally is like super expensive. So these ones I got for free at some point from something. Especially these black ones. These are generally quite good. Oh no, there's only 8 pounds. Yeah. That's like a shitty grade. I really like to use 10.9 or 12.9, but of course they are more expensive. And buying screws local is kind of so expensive. In China, they're very cheap. You only have, even in China, there is, for the big companies, like relatively low amount of. Yes, all these screws are steel. And this is PLA CF from Esun. I picked this brown color because it was the cheapest. So the whole 1 kilo roll was. That's some discount because nobody bought this color. So I have, and basically all my cabinets in this one, and let me quickly check the time again. Oh, we still have some time. I also have this cabinet here. I also got this one not that long ago. Cabinets are very expensive, so this one is still a little bit disorganized. Here's all pneumatic fittings, again, all from China. So in China, these things are like super cheap. Yeah, so this is EPLACF. So I've had very good luck with it in all kind of situations. I just like printing it like this. This doesn't have to be strong. All of these fittings. Again, in China, this whole set is probably like $100. So in China, these things are very cheap. These are random toolboxes, electrical connections. What is this? This is random tools of electronics or no, yeah, electronics related stuff. So this is a fan regulator for an electrical cabinet. Some fans. Again, all of this stuff is from China. Like, and when I say from China, like directly from China. Some directly from a Chinese vendor, so not on AliExpress or Alibaba or this kind of stuff. Yes, we have Wago. This is Wago 2-to-1. Wow, these ones are from just Europe. Like these. You also have these. Also some German thing. I only bought them because they were cheap. But for like electrical house stuff, these ones are kind of good and like super cheap. Like you can buy probably like 1,000 of this for like $20, but 1,000 of these is probably like $100. It's quite a big price difference. Most of the stuff I actually never use. That's just whenever you need it, you need it. There's some break out whenever you need this. It's very handy. There's some pneumatic parts. These are all like breakouts for our like sub-D connectors, all this kind of thing. It's all kind of random stuff. Yes. Oh, actually for my CNC build, I bought all of these connectors. I'm not going to be using them because these all need to be soldered. and soldering this kind of connection is a lot of work. So I'm going to use a different system now. So I have all of these left over. This is electrical stuff. So like breakers, boxes, connectors, more wagos. Yeah, this is some kind of pressure, SMC pressure thing. Also in China, this is like $3 or $5. It's like super cheap. Yeah. Yeah, I'm wiring an entire house because I'm doing a lot of renovations here. Like it kind of looks sketchy, but it's pretty good. So I have a lot of, like there's a bunch of cable hanging around. This is all stuff for the laser, which came with it, earplugs. This laser can also weld. So it has all these attachments and laser heads and all this kind of stuff. These are some lenses, because there's like this protective lens in front of it. Yeah, cables, random stuff. So this is my drawer of, how do I call this? Mechanical things. So these are giant couplers for connecting servos to, well, basically I use it on that machine. So connecting the servo to the axis. These are like giant things. So they're basically the size of my hand. I also got these custom made in China. Quite cheap, like $10 or so. Planetary gearbox. And here you can see this is an adapter. Also I got custom made because I needed to convert this gearbox into this one, which then goes directly in the tool changer of this machine. And getting this whole custom part made to my dimensions was $15, something like that. These are all for orientation locked. Okay, whatever. So these are all for distributing oil. Needs to stay in the correct spot. This is my tape and glue drawer, which has some arbor adapters, but just ignore those for now. We'll organize that at some point. This is random tools, because these two cabinets are going to go in the trash because these are not very good things. Yeah, this gearbox, let's see how much torque is it rated for. It actually doesn't say, but I think it can probably handle like 80 Newton meters, something like that. 80 to 100. So these random tools need to go away. What is this? This mechanical stuff. So here you have another gearbox, Planetary 1125 with a Delta B3 servos. Yeah, all of these things are Chinese. If you had to buy this thing in Europe or in the US, you'll spend so much money. B3 servo drive. What is in this drawer? More mechanical. So this is a computer. This is a VFD for the spindle, which is currently in the machine, but I replaced it with a better one. And this is another Delta MS300 VFD. Again, in China it's very cheap. So in China this costs only like $100. Renishaw tool setter, which is here somewhere. Oh, here it is. I bought this used from China. Most of them are spares, but actually, like, I'm retrofitting this CNC machine. So I actually already got it working in the past, but then I didn't like the electrical cabinet. I have to go around all this crap. So I didn't like my electrical cabinet, so I ripped it all out. You can see all the servo drives, X, Y, Z. One is for the tool changer, and this is the new VFD, also Delta PLC. Something I'm going to make a video about soon. Yes, this is a pendant. so you can control it while standing in front of the machine or around. And here I made, in my channel you can see a video about me making this. Well, I work, for example, with PCBWay. Well, work. They buy some advertising spots here and there. Yes, pendant. So this is my. If you go on my channel, you can see I made a video about this breakout board. No, this stuff is not from Temu. Temu has generally quite a lot of crap. This really comes from, like, I lived in China for about, yeah, anyway, I press a button and then it suddenly goes away. So I lived in China for about 4 years. It's also like 6 years ago. And I can talk to basic Chinese, but I have a lot of contacts there. So put up my phone. So I have a lot of contacts there. So I buy stuff directly in China, then put it. I have a warehouse there, so I can reship things, inspect things, etc., etc. Let me finish this tape part. But I need to work on that CNC soon. Let me think. Like, it's super easy to make it to work because I use a Centroid controller. Those are very easy to actually set up with things which are normally quite hard. So the hard things are normally connecting to the servos. Like, these are EtherCAT based, so basically Ethernet, but then with a bit more real-time layer. Normally that's quite difficult. So if you use Linux CNC or this kind of stuff, this is quite a pain to do. With Centroid, you can see it on my channel. I have a short about it, and also a video about the Kitamura rebuild. So it actually, I got it working, but I didn't like the layout of my electrical cabinet. I found it too messy, so I decided, you know what, I'm just going to rip it all out and just do it again properly. And it has been like this for 6 or 8 months, and I'm doing a rebuild on my house and my workshop and all of this kind of stuff. So I've been very busy in this. Yes, so this is Centroid. So it uses Centroid CNC. So if you have Google, look for Centroid CNC, or look on my channel. I have a short about it, about the servos moving. I got that. Well, I wanted to use that controller anyway. But being the business person I am, I reached out to them and I said, I'm doing this build. I see you have no social media presence, etc. So I said, give me the stuff free, and then I will include it. They didn't give it to me for free. No, I think I actually said I wanted to pay money for it. And so I have a build log on that forum, and I think I'm basically the only person who has footage, or like advertising is a big word. Let's just call it showcasing of their product on YouTube. So I basically own the entire market on this controller, but I actually wanted to use it. I just wanted to spend money. That's why I reached out to them. And I was like, well, I'm going to make a video anyway. So if we can make a deal which is beneficial for both people. So I got it for about half price. So they didn't lose any money on it. No, this pendant is like really good. I used one for Linux CNC before, and that was a Bluetooth based one, basically the same one. Like, they get this with some custom firmware or whatever from I think pretty much the same supplier, but this has literally no lag. So with Linux CNC, I used basically the same style, but then the Bluetooth version, and that had quite a bit of lag. So even you're turning in a certain direction, and like sometimes you have to wait 1 or 2 seconds for it to stop. Like, this stops instantly. So I think they use two-way communication in this one and RF. So this works quite a bit better. So overall, I'm quite happy with Centroid. Things which is a little bit less nice is the price, of course, but in the end, they are an American company with American wages, so that's kind of expensive. and this stuff just works. The only downside is because, well, it's proprietary. It's kind of closed off in some way. So they have like an internal PLC, and that thing you use for like, this thing has an automatic tool changer. These things you normally do with a PLC. The problem is their PLC is very basic. So it can't do digital communication. It can basically only do input outputs. It can't do analog measurements. Just there's 32 IOs, and yeah, that's it. Can I get it to work with that? Probably yes, but I don't want that. You could try the RF version of that end for Mac 3 or Linux CNC. I don't know if that really solves the problem, but I know what you're talking about. I had the same issue with Linux CNC. So this pendant is also wireless. This works perfectly. I don't know if it's just because Centroid did a better job, or but I would say don't use the Bluetooth version if you use the RF version, because RF has very low latency by itself. Maybe it already solves most of your problems. I don't know if you will get the same level as Centroid does, but you should get pretty close. I'm going to close this. Yeah, I had the Bluetooth version. The Bluetooth version I don't think is very good. The strange thing is you don't see anybody talking about it. So when I said to other people like I'm having issues with this, it's like really laggy, everybody looks at me like I'm crazy. But it's interesting to hear that I'm not the only one. I would suggest again try, yeah, because especially like you can get into some quite dangerous situations. So if you have a lot of lag, you need to move very slowly to make sure it doesn't like overshoot and runs into something. I would say try the RF version, and if that doesn't work, yeah, you can always do wired. But RF should be quick enough for this. But yeah, these pendants are kind of expensive, so yeah. I have a lot of experience with that. So if you look on my channel, you can find a CNC called the Mighty Mill. So I made a router kind of machine in the past that I ran Linux CNC on that, and I crashed it quite a few times, basically in the same way. So this pendant is quite expensive. Like I think Centroid sells it for like $300. And the reason their pricing is a bit higher because again, American company, but their target market is basically like retrofitters, so businesses, and businesses have money. So this pendant costs like $325. It's kind of expensive because I think in essence it's basically the same thing as like the $80 one, because it's from the same brand. So the XHC is a Chinese brand. So this one is from the same brand. They just say there's a Centroid sticker on it, and well, there's some different printing on the buttons. If there's actually hardware difference, I have no idea. I would kind of doubt it, to be honest. I think it's just maybe some software change that they do some error correcting, so they don't send a signal once. They maybe send it like 2 or 3 times with some CRC to prevent missteps. But again, I crashed with a decent end mill, can already cost you $100, and I've had a lot of those. So in the past, when I had a bit more time, I can be quite frugal, let's just say it like that, or cheap, depending on who you ask. I also tried indeed making it cheaper, like the Centroid board. That's kind of expensive. I don't know what the current pricing is, but at the time it was like $1,800. It's like not that cheap, and then you also have to buy software. Depending on like all the features you need, is either free or the highest tiers, like maybe $500. Of course, as I mentioned earlier, I kind of got a deal on that, so for me that's not really a problem. But for DIY builds, it's kind of on the high side. They have the Acorn range, which does the same, but then it's on either. Then it's just like normal step there and not EtherCAD. So what makes this expensive is EtherCAD, which is kind of strange because EtherCAD actually makes things cheaper because it's just a communication line. You save a lot of hardware to use EtherCAD, but this puts you more in the like professional sphere. So I understand it from a business point of view. And one good thing is you kind of get what you pay for. So you pay more, but you actually get something which works. You can, I called it setup, from like taking it out of the box and connecting it to servos. I think in like 30 minutes, I got it all working. It's just crazy. On Linux CNC, I've spent days and days and days getting my setup working, and even then it didn't work perfectly. This basically works out of the box. And Centroid has been doing this for like 25 or 30 years, like a crazy amount of time. So I guess they learned a lot during this period. What works, what doesn't work. And they implemented that into their systems. So here they are. Yeah, I'm getting more and more into the mindset of buying proper tools. It is difficult. Hey, it's good to see you, man. I'm actually just closing off this this live stream. So what we did, we made these, cut this on the fiber laser, then bend it on the press brake so we can watch the vault later. And in the end, I can show you, it becomes this. So I made some 3D printed inserts. This actually has the taper of a BT30. I actually got Claude AI to make this because I didn't want to spend my time. So I basically gave it 2 prompts and it made this part. So that's pretty good. Let me get a quick tool. So now all my tools are hanging around in drawers, etc. And so here's one. Fits in this. And I'm planning it to either, yes. Yeah, the thing is, oh shit, I really need to go. I'm sorry, guys. But the thing is, that's like internal, there's like a draft inside. And I need to figure out that that angle, etc. I was like, okay, Claude, I need this, blah, blah, blah. Make sure this angle is correct. Make sure there's clearance. And I was like, okay. And like a few minutes, well, 1 or 2 minutes later, he gave me this part. So this goes on here. Or somewhere else. I need to figure that part out. But at least it's there to organize my tools. Anyway, guys, I will do a live stream again at some point. I kind of enjoy this because normally it's just me working. At least now there's some nice interaction. So I wish you all a good night or day wherever you are, and maybe we see each other the next time.